On this section of the polynomials, we're going to look at polynomials in factored form, and we're going to find the zeros for each one. So in a way, we're looking at really solving these, but it's not going to have an equal sign here. We're just going to identify what the zeros would be. In this first one, going back to an old factoring, all those methods, the first thing that you always look for when you factor is the greatest common factor. Don't forget that. So many people do forget that, but I'm looking for the GCF, or the greatest common factor. In this particular problem, I have a greatest common factor of x. So that would leave me x squared minus 36. Then I have a difference of squares, or I have a binomial. If you have a binomial, you have to look for the difference of cubes or the difference of squares. So I'm going to factor this difference of squares. So this is x, and then you're looking at this saying, okay, the signs will be different. X plus, x minus. And then what are those squares? What square gives you x squared is x. What square gives me 36? 6 times 6. So this is my factored form. X plus 6, x minus 6. Now when we identify the zeros, we go through and we set each one of these equal to 0. X equals 0, x plus 6 equals 0, and x minus 6 equals to 0. So my zeros are 0, negative 6, and positive 6. So if we're identifying the zeros would be negative 6, 0, and positive 6. Sometimes you may see it written like this, 0 plus or minus 6. Either way is fine. But if they ask you to find the zeros, it's just as if it were set equal to 0 and we were solving it for x. So this is number 7 from your worksheet. Number 8. On number 8, again, we're looking for the greatest common factor first. Always look for the greatest common factor first. In this case, I do have one. It is 3x. When I factor this out, 3 will go into 9x cubed, 3x squared times. 3 will go into 6x squared, 2x times, and then 3x will go into 3x, a minus 1. You cannot forget that minus 1. If you were to distribute back, you would get that same trinomial here with a degree of 3, if we're looking at all that. So I know that I factored that 3x out correctly. Now I want to keep the 3x, and then I'm going to bottoms up this particular trinomial. I need to factor it. So I have 3 times 1, so x squared plus 2x minus 3. You're going to just bring down that 3x, it just sticks with it. Set up your two binomials, the signs will be different. X plus, x minus. What are factors of 3 that subtract and give me 2? 3 and 1, and that 3 gets that plus sign. Then if I multiply in by 3, I have to divide out by 3, and you can't forget that. That's very, very important. So here I have 3x times, this reduces to 1, and this bottoms up, 3x minus 1. If they ask for the factored form only, I would stop right there. If they're asking for the zeros, you set each one of these equal to 0. It all depends on what the directions tell you to do. I just want to go through both steps. So x is equal to 0, x is equal to negative 1. Add 1 to both sides and divide by 3, and x is equal to 1/3. So the zeros here would be negative 1, 0, and 1/3. Nothing is repeated, so there's not a multiplicity. Let's do one more. So number 9. On number 9, again, we look for a greatest common factor. In the greatest common factor, this problem would be 5x. So I'm going to take out the 5x. 5x will go into 10x cubed, 2x squared times. 5x will go into 10x minus 2x times. And 5x will go into 15x, a positive 3 times. So here I look right here. I'm going to factor this, and I'm going to use bottoms up. So I'm going to keep that 5x. So 2 times 3 is 6. So I have x squared minus 2x plus 6. Keeping the 5x, I'm going to factor this trinomial. The signs will be these same. They will both be minus, x minus, and x minus. Now what are factors of 6 that add and give me 2. What are factors of 6 that add and give me 2? In this case, there are no factors that add and give me 2. So I'm not going to be able to use bottoms up with this method. So here, I'm going to try that because it's probably the easiest method to use. So I'm going to erase this part here. And I do know, however, there is another method to factoring. I can complete the square or I can use the quadratic formula. I will probably alternate back and forth. So I have 5x times. I'm looking right here. I've got to go back up. I'm looking right here at this particular trinomial before I took out that 2. Can't divide by 2 yet. Take all this off so it's not confusing. So now I've got to go back. Bottoms up didn't work, so I'm going to use the quadratic formula. So if I look at my trinomial here, a equals 2, b equals -2, and c equals 3. Now I'm going to go find that discriminant. The discriminant is b squared minus 4 times a times c. We're going to calculate that. And I get -20. So we have b squared minus 4, and here's my a and my c. So the discriminant is -20. When I go to plug that in, I have x equals the opposite of b, which is 2, plus or minus the square root of -20, all over 2 times a, which is 2. So I have x equals 2 plus or minus, and I'm going to take the square root of 20. The perfect square in 20 is -4 times 5, and the square root of -4 is 2i, and then the square root of 5 just stays underneath that radical. So I have plus or minus 2i square roots of 5, all divided by 4. Since all 3 of these numbers that make the little triangle are divisible by 2, I divide out the 2. And I have x equals 1 plus or minus I square roots of 5, all divided by 2. I'm dividing everything by 2. So here are these answers here. Another thing to look for that I didn't mention before is that my highest exponent, or my degree, is 3. That tells me I'm going to have 3 answers. Right here I have 2. I have plus or minus. If I were to expand these answers here, these would be 2 of my answers right here. The other one's going to come from 5x. So there's what x equals there. If I set 5x equal to 0 and solve, then x is equal to 0. So here are my 3 answers. Right, here's 1, and here's 2 more. So I'm going to write those in totally expanded form. I'm running out of board space. Right up here. So x is equal to 0 and 1 plus the square root of 5 over 2, and 1 minus the square root of 5 over 2. Now, I don't mind if you put plus or minus. I just wanted you to see that there's going to be those 3 answers, and that degree tells me that. So this is all over the board. I think you'll be able to follow, and I'm sure we'll work another one. If you can't bottoms up, then you've got to go to another method, either completing the square or the quadratic formula. We'll continue these on the next slide.